In this video, we're going to be talking about service valves and service valve positions. Now, there's a variety of valves installed in the HVAC systems to provide easy access to the systems. Service valves are used to monitor system pressure, to recover refrigerant, to charge a system, and to pull a vacuum. Some valves provide only basic access to the systems. Others provide more control because they have multiple valve seat positions to open and close parts of a system for isolation. Some valves provide just a connection to the refrigeration system for taking pressures or adding and removing refrigerant or lubricant. This is an example of a basic access valve. You have a valve stem cap, you have a Schrader port with Schrader valve, and you have an inlet and outlet. This is the type of valve you're going to find on the side of most condensing units. Service valves gives the technician opportunity to seal off parts of the system while installing gauges, recharging, or evacuating a system. They require the use of a refrigeration service wrench to turn the valve stem. The valve bodies are usually made of drop-forged brass. Service valves must be leak-proof where the valve enters the valve stem and where the valve stem enters the valve. Similar to refrigerant cylinder valves, service valves have packing installed around their valve stems. Valve stems are made of steel or brass. Before changing a service valve's position, loosen the service valve's packing nut one turn. Skipping this step could cause the valve to leak. Once you finish positioning the valve for a procedure and before returning the system to regular operation, tighten the packing nut. Service valves are sometimes found on compressors, liquid receivers, evaporators. They're either connected to these components by pipe threads or bolted flanges. Service valves have 4 different valve positions. They're back-seated, they're front-seated, they're mid-seated, or they're cracked open. And this is just an example of the different service valves, okay? Front-seated means the stem is all the way in. You'll see that the connection on the left side is all the way closed, because when you look at these diagrams, there's actually a port there, there's a port there, and there's a port there. Back-seated means that we've pulled the valve stem all the way out and the gauge port is closed. Still have a path from whatever this is mounted on to the piping. Valve in a mid-seated position, sometimes known as cracked, I have a flow of refrigerant this way and I have a flow of refrigerant through my gauge hoses. So this is my normal operating position, back-seated. Mid-position or cracked or mid-seated is where I'm servicing the system, where I'm checking pressures, adding refrigerant, adding lubricant, etc. Front-seated, we never run a system in a front-seated position. Or I'm saying we rarely run. There's a few occasions. Okay, when the valve is all the way out, the valve is back-seated. When the valve stem is back-seated, it closes off its service port from the rest of the system, so no pressure readings or procedures can be performed. The back-seated position is used for normal system operation. If a valve stem is turned clockwise or inward as far as possible, the valve is front-seated. When the valve is front-seated, it blocks the flow of refrigerant to the valve by closing its regular passageway. By front-seating the valve, we provide a passage between part of the refrigeration system and the service port. When the valve is turned so that the valve is not against either seat, it's considered mid-seated. This is usually done by beginning with the valve in the back-seated position and turning the valve stem 2 complete rotations. When the valve is in this position, it accomplishes 2 things. First, it allows the refrigerant to continue to flow as normal, and second, it provides a connection between the rest of the system and the service port. For simple pressure readings, the service valve is just cracked open. The cracked open position is similar to the mid-seated position. It allows the refrigerant to continue flowing while providing a connection between the rest of the system and the service port. A service valve is cracked open when the valve stem has been turned in just enough to lift the valve off the back-seated position. Cracking open a service valve begins by having the valve in the back-seated position. Then you rotate the valve stem 1/16 to 1/8 of a turn clockwise. It's good practice to crack open a service valve before opening it fully. Cracking open a service valve prevents a shock pressure rush, which can damage gauges or injure a technician if enough pressure is built up. So you want to be careful when you're opening service valves. Open them slowly. Low side service valves are usually found on the low side of the system. A suction line service valve is a low side valve connected to the system's suction line. In many cases, the suction line service valve is located much closer to the compressor inlet than the evaporator. It's often found on the condensing units of a split system. During normal operating conditions, cool, low-pressure vapor flows through this valve. A suction service valve is a low-side valve that connects to the suction line and directly onto the compressor at its inlet. A suction service valve is considered a compressor service valve because it is one of the two service valves connected directly onto the compressor. Valve caps protect the service port and the valve stem when the valve is not in use. Make sure you keep these caps tight on both when the valve is not in use. So again, in some systems you'll find a suction service valve directly mounted on the compressor. You have a valve stem cap, there's a connection to the compressor, there's mounting bolts, and there's a suction line connection. There's also a service port. Keep all the caps on as much as possible. When a suction service valve is front-seated, the suction line's passage into the valve is blocked, but a passageway exists between the service port and the valve outlet in the compressor. By front-seating the valve, a technician can remove the suction service valves from the compressor while leaving the suction line sealed. You don't necessarily have to recover refrigerant sometimes. Okay, so again, we have a 3-position valve. If we push it all the way in front-seated, we can seal off that suction line, but have a service port available connected to the compressor. High side service valves are commonly found on the high side of the system. A discharge service valve is a high side valve that is mounted at the compressor's discharge port, providing a shutoff between the compressor and the condenser. A discharge service valve has the same 4 positions as a service valve. When the valve is front-seated, the passage out of the valve into the discharge line and the condenser is blocked, leaving the valve inlet from the compressor and the service port isolated. Front-seating a discharge service valve allows the valve to be disconnected from the compressor without refrigerant escaping from the condenser. Now this is important also, there's a safety note here. You never run a compressor with that discharge service valve front-seated. You'll blow the cylinders out. So again, we have a discharge service valve and we have a suction service valve. So let's say we need to change a compressor on the system. We can close the suction service valve. We can close the discharge service valve. Then we can recover the refrigerant, and by close I mean front seat. Then we can recover the refrigerant just out of the compressor. We can unbolt these from the compressor, change the compressor, rebolt them, put the compressor into a vacuum, and then when we're in a vacuum, we can open the service valves and we can let the refrigerant from the system back into the compressor, and then it just fix the charge. A liquid service valve is a high side valve located in the condenser and the liquid line. In many cases, a liquid service valve is located much closer to the condenser's outlet than the metering device and is commonly found on the condensing unit of a split system. A liquid receiver service valve is found on the high side, is a high side valve connected to the outlet of the liquid receiver and the inlet of the liquid line. These valves are often 3-way valves and enable a technician to charge liquid refrigerant into the system. Liquid line receiver service valves are also called king valves or receiver outlet valves. Another service valve is called the queen valve, which is installed between the condenser outlet and the liquid line receiver inlet. These valves are useful when pumping down systems for component operation. Most service valves have a brass body and a steel stem. The stems have a tendency to rust and to score the valve gland or the packing. Always clean and oil a valve stem before turning it. A dirty valve stem will ruin the valve packing. Valve stem rust can be reduced by coating it with a little refrigerant lubricant before replacing the valve stem in the service cap port. Use lubricant specified for the refrigerant in that system. Service valves must be in good condition. 3 things should be done to maintain good operation and extend the life of a service valve. First, match the correct service valve wrench size to the valve stem to prevent stripping the valve stem heads. Do not use an adjustable wrench or fixed open-end wrenches. Absolutely use refrigeration wrenches. Maintain the packing so the service valve does not leak. Oil the threads of the service port each time gauges are used. There are 3 various parts of the system where a technician must access the system to measure pressure without stopping the flow of refrigerant or completely opening the system. Such areas are good places to install access ports. A refrigeration system access port is a small valve opening that usually contains a Schrader valve core and is used for checking pressures and servicing a system. Access ports are often installed at an evaporator outlet or a liquid line inlet and are typically installed just ahead of the metering device and on both sides of the automatic valves in the system. Access ports may be installed prior to metering devices, solenoid valves, bypass valves, hot gas defrost valves, and dryers. This is an example of an access port. Okay, again, we have a standard flare cap threads. We have a core, the Schrader core inside. These are threaded so they're easily replaceable. Okay, and these normally fits 1/4 inch tubing. Okay, if they're threaded on the outside. The tube can be opened by depressing the pin against the spring pressure. Refrigeration hoses have a pin that pushes the Schrader valve open as the hoses get tightened into place. When the hoses are removed, the spring pushes the Schrader pin back into the closed position. Having external threads allows the Schrader valves to be used as valve cores inside access ports. A valve core can be removed from the access ports for certain procedures such as pulling a vacuum. Technicians use Schrader valve core removers that mount on the access port to remove Schrader valve cores for charging and evacuation of system. This tool also allows for replacing a defective Schrader valve without losing the refrigerant charge or vacuums. And this is just an example of a Schrader core remover. We put this on here, we put our gauges, we put this onto the Schrader valve, put our gauges on here, and then by turning and pulling the rod, we can actually remove that Schrader valve core. Close the valve handle, we isolate now the removed core, and we can change that core out without a loss of refrigerant, or should I say a de minimis or minor loss of refrigerant. We also want to pull Schrader cores when we're trying to put a system into a vacuum, in other words, evacuate it. The Schrader core slows down the vacuum procedure, and we can get a much better vacuum if we remove those cores. The piercing valve is the next valve we're going to talk about. It's a common way to gain access to small hermetic systems or if used without access ports. A piercing valve is a valve that clamps onto a system and pierces through the tubing. Piercing valves may be mounted on a suction line, discharge valve line, or both. There are 2 general designs for piercing valves. You have a bolt-on, you have a braze-on. Brazed-on piercing valves seldom leak, but require refrigerant removal from the system prior to brazing. You cannot braze a system that has you cannot braze a system that has refrigerant in it. It's unsafe, and the braze won't work. Bolt-on piercing valves do not require refrigerant removal prior to installation, but will leak over time. Bolt-on piercing valves are recommended for temporary access and should be removed and replaced with brazed-on valves. So what happens here is you take a piercing valve, okay, it comes in multiple parts. Okay, you clamp it on the line by tightening these bolts, and then you use a hex wrench once it's mounted to pierce that needle through the refrigeration lines. Okay, and of course it has a Schrader access valve on one side of it, or it has an access fitting. Once you have the refrigerant out of the system, you do have to put in a first you have to seal the leak, but the best way to do it is just cut out that piece and put in a T with a Schrader access valve.